Okay, so 3. So if I have my polar paper out, looks like this. So 3, this is pretty big grid. 3 would mean this is 1. The first circle is 1 away. The second circle is 2 away. The third circle is 3 away. So 3, an R value of 3 is that far away from the pole, or 0, 0. And then what's 5 pi 6? How many degrees is that? It's all the way over here, right? Okay. So, hold on a second. We got to do our labels. I know. This is 0. This is obviously 45. It's going to count a minute to see how many. 1, 2, 3, 4, 5, 6, 7. Is it? These are each 10 degrees, I believe. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. Okay, so each of these little things is 10 degrees. All right, so 5 pi 6 is 30 degrees shy, right, of 180. So if I would rotate around, here we go. Now it's at 90, or pi halves. 90, and then I go around here. This is 108 if I were at 180, but I wanted to be 5 pi 6, so we said that was 30 degrees shy of that. So I'm going to go back. Okay. Okay. So what I did again was I went out 3, this is 3, and then I rotated 5 pi 6, which is 150 degrees around. This is the point. I was just showing how I got there.
Okay, so like if actually this is like that line.
Nope, just this point. Okay, so notice 5 pi 6 is a positive number, agreed? But if I were to make this an x-y axis, wouldn't these coordinates both be negative? Okay, so let's do the conversion now to the x-y axis. So like if this was instead the grid, like normal, like we have grids up and down, what ordered pair would this be? Alright, so let's remember this is r and this is theta. Okay, and then let's go back over here and use our conversions. And then we're going to think unit circle, because we're still not going to forget that. 5 pi 6 is exact, so I can do it exactly. If you don't have an exact one, you're going to just punch it in your calculator. So to find x, it should be 3 times the cosine of 5 pi 6. And to find y, it should be 3 times the sine of 5 pi 6. Okay, so 5 pi 6, the cosine is negative root 3 over 2, and then the sine is 1/2. Kind of sort of remembering this? Okay, so 3 times negative root 3 over 2. Let's see what that is about. It would help if my calculator was on. So approximately negative 2.598. And the sine of 5 pi 6 was 1/2, so this would be 3 times 1/2, which that's just 1.5. So it's rectangular points. Rectangular refers to x and y. Would be negative 2.598 and 1.5. Okay. So if I look, it would be fun if we could have it like an XY axis on here, but does this look like this could be over negative 2.59? and up 1.5, like if I was doing my old way of graphing. That makes sense, because it's to the left and then up. So when we're doing polar mode, we're basing it on a circle. When we're doing rectangular mode, we're just basing it on the same old positive is right, negative is left, or up and down. Okay, so let's do another one in degrees. Let's graph Q with the points to, let's do negative 200 degrees. So this is in polar mode, R and theta. And then we're going to find its rectangular coordinates or points. What does a negative degree mean? Yeah, instead of going up, we're going to go down from the x-axis. Alright, so, get our polar paper out again. So I'm going to go 2 out, so it's right here, 2 away. And negative 200 degrees, remember how I said each of these was a 10 degree? So I'm going to go this direction now. Okay, I'm stopping. That's negative 90, right? Okay, keep going. This is negative 180, 190. That's where that point would be.
What if you just like added 360?
Yay, we're going to talk about that next. Let's talk about it now since she said it. You could get an infinite number of points that get you to the same spot. Did you hear what Lindsay said? What if you just added 360 to negative 200? Would you do that a second? What is negative 200 plus 360? 160, right? Isn't this the same as going 2? And then what if I went positive 160? Don't I end up in the same spot? Yeah. Okay. So you can find multiple polar coordinates. I'll write this down in our notes in a second. By adding 360 onto the angle. Hey, what if I decided to start, let's do the same one. What if I didn't go positive 2 from 0, 0? What if I did negative 2? What if I had gone this way first? How could I get to that spot? You guys tell me. So what if I had started, instead of going positive 2, what if I went negative 2? How could I get up to that spot? By going up how many degrees? 20, and that's, since we're going clockwise, isn't it negative 20? Okay, so there's another way that you can get polar coordinates by making the x-coordinate negative and then subtracting. Okay, so I'm going to write those down in a second. All right, let's convert them though. What if I wanted to know some other points? Yeah, some other ways to get there. Or let's say I had a negative angle and I wanted to make it a positive angle, things like that. All right, we are doing degrees now, so what mode should we be in? Degree. So we're going to punch this in our calculator because we do not know the cosine and sine of this exactly. We're going to do 2 times cosine of negative 200 and 2 times sine of negative 200. Okay, so let's do that. Oh, I'm already in degree mode. Cool. So I get negative 1.879. And for the second one, I get 0.684. And if you look at your polar paper again, that would make sense on the xy plane because it's to the left, which means the x-coordinate would be negative, and then the y-coordinate would be positive. Okay. How we doing? Good so far? Alright, so let's